Okay, today we're just going to talk about vertical stretching, shrinking. That scared me. Go Tigers. She's interested. She's just trying to see what I'm doing. Proud of you for paying attention. So we're only going to be talking about A and B. So one video we talked about the vertical shifting up and down, the horizontal shifting left and right. The next video we're going to talk about everything all together. A, B, H, and K. And you're like, oh my gosh, there's no way I'm going to be able to do that. It takes practice. It won't be that bad. Today we're just going to focus on A and B though. So we won't have any shifting up, down, or any shifting left and right. So some of this language can be kind of weird, but let's take a look at it. So the absolute value of A, the reason it's written this way is because if this is a negative, you're not really looking at the negative yet. The negative does something, but you're only looking at the number attached to that negative. So the absolute value of A tells us that we're going to have a vertical shrink by a factor of. We take by a factor of, and we just write it as BFO so we don't have to say that a million times. So by a factor of A. Now, meaning that if I had A was equal to 4, and I had a big lump of Play-Doh, and I took this and I vertically stretched this Play-Doh. So I grabbed this Play-Doh lump and I stretched it vertically, meaning up and down. What's going to happen to the Play-Doh? Well, it's going to get skinnier. In the same way, if I had my V-shaped graph and I started pulling from the top and bottom, it's going to get skinnier. It's going to come and be a smaller V. So that's what a vertical stretch does. Now, what if this is a fraction? What if this is something like 1/2 or 1/3 or 2/5 or something like that? When we have a number in between 0 and 1, then that's going to be a vertical shrink by a factor of A. So again, take that Play-Doh, that big lump of Play-Doh, and I press down from top and bottom. The only way that Play-Doh has to go is out, right? So in the same way, if I have a V-shaped graph, and I press down from top and bottom, the only way my V can go is out. So a vertical shrink makes that V wider, makes it larger. Okay, now what about if A is negative? So if A is negative, that means it's going to reflect or flip over the x-axis. So if I see a negative number here, that is where I want to pay attention. That means it flips over the x-axis. So instead of a V shape that points up, I'm going to have a V shape that points down. B, if the absolute value of B, so on the inside of the function, remember how we talked about the outside of the function is vertical, and so we're going to use VO for outside of the function, but inside of the function, we're going to use HI, the word high. So horizontal, shifting, stretching is on the inside of the function. So in this case, B, when B is greater than 1, this is a little opposite. So this is a little challenging. When B is greater than 1, it's opposite of vertical. It's not a vertical stretch or horizontal stretch. It's a horizontal shrink. And then it's by a factor of the reciprocal, by a factor of 1 over B. For example, if B is 3, then 3, I would have a horizontal shrink. I'd be pushing in from left and right. So again, if I had a big lump of Play-Doh and I pushed in from left and right, what's going to happen to that Play-Doh? It has nowhere to go but up and down, right? So in the same way, if I had a V-shaped graph and I pushed in from left and right, it's going to get skinnier. Now, what's going to happen is that a vertical stretch is going to look the same as a horizontal shrink. And a vertical shrink is going to look the same as a horizontal stretch. Now, guys, listen to me. This is not a pickup line. You can't go up to somebody and be like, wow, you look like you vertically stretched, or like you horizontally shrank. It's not going to work. I tried it. It didn't actually work. So don't do that. But anyway, what happens if B is negative? If B is negative on the inside, that means it's going to flip or reflect over the y-axis. The thing is that if I have a V shape here and I flip it, it's still a V shape. So actually, with absolute value in parabolic functions, we don't really have to worry about the reflection over the y-axis, but there are functions that we will deal with where that will actually change what the graph looks like. Okay, so let's do some examples. This is a lot of words. Let me quickly, I don't think I said this, sorry. Quickly let me talk about this 1 over B. So if B were 3, then that would be a horizontal shrink by a factor of 1 over 3. Now what if it's a fraction though? If B is a fraction, like 2/3, then it'd be a horizontal stretch by a factor of, instead of 2/3, we'd take the reciprocal, so it'd be 3 over 2. What if B is like 1/2? Then it'd still be a horizontal stretch, right? Horizontal stretch, because it's a fraction, something in between 0 and 1. But 1/2 though, the reciprocal of 1/2 would be 2 over 1. So it would be a horizontal stretch by a factor of 2. I am using words like fraction to denote horizontal stretch. But I want you to be careful. When we see a fraction, technically, not all fractions are in between 0 and 1. Like I could give you a fraction that's 5 over 4. That's technically 1.25. So that wouldn't really be a horizontal stretch. It would actually be a horizontal shrink because it's larger than 1. I'm not going to ever give you a fraction that's greater than 1. I don't think your teacher would do that either, I hope. But just keep in mind that yes, I'm using words like fraction, but not all fractions are in between 0 and 1. But when you see a fraction, immediately you can assume if it's on the outside, hey, this is probably a vertical shrink. If it's on the inside, it's probably a horizontal stretch. But just kind of quickly see, is this greater than 1? If not, then you can go with what your original gut said. All right, let's take a look at some examples. All right, let's graph these two. All right, first we'll do in blue. So this first graph, I have a negative 2/3 x. So this is on the outside. So because it's on the outside, it's going to be vertical. So we have to figure out, is this a stretch or a shrink? So if you want to go back and pause that video to write down those notes, or if you're in my class, probably I gave you a paper copy or I put it on Google Classroom. But if it's a fraction, a number between 0 and 1, which 2/3 is, it's 0.6 repeated, then we can say that this is a vertical shrink. So we can say vertical shrink, and we're going to say by a factor of whatever a is. In this case, it's 2/3. And we're not talking about the negative. The negative is not a part of it yet. We're gonna kind of look at that and save that for later. But this is a vertical shrink by a factor of 2/3. Now I'm not going to do this every time, but here is the parent function. Remember, it has that slope of 1, and it's symmetrical about the y value of this vertex. So it could flip over this invisible line here, the line of symmetry. So if it goes up 1, right 1, it also goes up 1, left 1 for absolute value functions. Now, vertical shrink by a factor of 2/3, why does that help us? Well, this almost acts as the slope. Some teachers aren't going to like that I say that, but truly from your vertex, our vertex is going to start at the same point because we don't have any shifting left, right, up, or down. But we're talking just stretching and shrinking. So this slope is going to go up to right 3. So what is our guess? A vertical shrink. Remember, if I have a V shape and I shrink it or press in from top and bottom, it should get wider. So let's see if that actually happens. So up to right 3. Up to right 3. And then in the same way, instead of up to right 3, because it's symmetrical, we can go up to left 3. So up to left 3, up to left 3. Notice how this is wider than its parent function. It is like they took that V and they made it just a little bit wider. Not by a lot, but just by a little bit. And if we were to continue those lines out forever, we could see that, you know, the difference would get more extreme. Now, what else do we have to do? We have this negative here. That's something that we need to pay attention to. So instead of going up to right 3, this now flips over the x-axis. This isn't a graph that points up. It's actually a graph that points down. So let's take a look at that. So still starting from the origin, but because it opens down, instead of going up to right 3, I actually need to go down to right 3 because it's flipping over the x-axis and it's pointing down. So down to right 3, down to right 3. In the same way, instead of down to right 3, I'm going to go down to left 3 and down to left 3. And so this V shape still is getting wider. It's harder to see as it flips over that it's wider than its parent. That's why we drew it first the regular way, so you can see, yes, it is actually wider than its parent. But because of that negative, don't forget that. That means it flips, so it actually points down. So we're going to go down to right 3 and down to left 3. Let's do one more example, number 2. So with number 2, we're going to use purple. This is on the inside of the function, so okay, inside, oh yeah, that's the word, high, so that's going to be a horizontal. Now it's trying to figure out, is this a stretch or a shrink? I don't know, it's a fraction, oh, but it's opposite of vertical, so Okay, horizontal, that's left and right, but it's a fraction. That's a horizontal stretch. So horizontal stretch, so horizontal stretch, and it just takes time, you just get used to it. And then it's by a factor of, but man, this was the reciprocal. Okay, so what's the reciprocal of 1 over 4? Oh, that's 4 over 1, which is just 4. So horizontal stretch by a factor of 4. So let's see, if I have a V shape and I stretch horizontally, that means I'm getting wider. So this graph should also be getting wider from its parent function. Let's quickly draw the parent function here, and then let's check to see if what we thought is true, see if it gets wider. Now, as you're getting used to this, go ahead and graph it, and then use your calculator to check. Is what's on your paper similar to what's on your calculator? The thing is that on a test, ACT or classroom test, you're not going to have enough time to graph all these on your calculator. It's going to take too long. It's better and faster if you practice using it without one and just using a calculator to check your work to know that you're on the right track, and then you start getting faster and faster, and you'll be able to graph this way faster than you could plug it into a calculator. And you're still paying attention. I'm proud of you. Eyes on me. Feel me? All right. So horizontal stretch by a factor of 4. Now this is positive, so we don't have to worry about any reflections. Even if it were a reflection, it wouldn't matter on the inside. But it's still slope. We don't have any movement left, right, up, down. But it's still, think of it as slope for absolute value functions at least. We're going to go up 1, right 4. Up 1, right 4. Now, because it's symmetrical, it's going to flip. So instead of up 1, right 4, we can go up 1, left 4. Up 1, left 4. And so we see a very, very wide V. Now, good news, bad news. Bad news is if you go up to somebody and you say, man, you look like you horizontally stretch, bro. That's not going to go well. The good news is they won't know what you're talking about. So, take that for what you want. Horizontal stretch by a factor of 4. So let's think about this. We have this 1/4. We thought, okay, horizontal stretch. It should get wider if I pull it from the left and right. And that's exactly what happened. Here's our parent function. Here's the one that we just graphed on the coordinate plane. And it did. It got wider. That was a lot easier to see than maybe this one. Now, practice these. Try to memorize those notes, the difference between if I have a whole number or fraction when it's on the outside. What does that mean in terms of by a factor of, and is that stretch or shrink? And then if I have a whole number or a fraction on the inside, what does that mean in terms of stretch or shrink? And is that by a factor of the reciprocal? So something to keep in mind there. High five.